In this topic, we discuss applications of linear equations. You might know these as the dreaded word problems, those things that haunt you from previous algebra courses. Well, they're not really that bad. To tackle these problems, you're going to want to make sure that you read through all of the problems carefully, watch as I do several examples, and then use that strategy to solve the problems. And finally, practice, practice, practice on your own. Watching someone do it and then doing it yourself is very different. So let's talk about a strategy as we encounter word problems. I suggest that you take the following steps whenever you encounter an application problem. Step 1. Wrap your head around all the information given in the problem. List every quantity described in the problem. Use a diagram and draw pictures whenever possible. Any unknown quantities, things that you're looking for, should be given a variable name like x. Step 2. Understand the relationships between the quantities in the problem. How does one quantity change as the others change? Form equations and expressions that describe how the various parts of the problem relate, and then put those expressions together to create a single equation that contains only one unknown, the quantity that you're looking for. And step 3, solve the equation from step 2. Make sure any solutions you obtain are feasible. Check your answers. For instance, if you get a negative width, you'd cross that off because you can't have rectangles with negative widths, etc. Alrighty, so let's put these steps to work and let's go about solving some application problems. First, as we start each example, we want to read it through carefully and make sure we understand the relationships and what the problem is talking about. Here we go. At example number 1. A university calculus class has 145 students enrolled in it. If there are 31 more female than male students enrolled in the class, determine the number of male students and the number of female students enrolled. Okay, so what this problem is talking about is we have a class, we have female students and male students. What exactly are we looking for? Well, often the thing that you're looking for is specified in the last sentence or the last phrase in the problem. In this problem it says determine the number of male students and the number of female students. So there are two things we're looking for in this problem, the number of male students and the number of female students. And I like to write this information out right away so that I know what I'm looking for. So let's do that. That is, we're looking for two things, the number of male students and the number of female students. Now, what we like to do is assign the variable x to one of these two unknown quantities. This is going to help us as we move on in the problem. So I am going to assign x to be the number of male students, and if it doesn't work out we can change it later, but let's let x be the number of male students in the class, something we don't know. Now, how can we represent the number of female students with x? For that we have to go back into the problem. It says, first of all, that there's a total of 145 students, which we could use that information, but on this next phrase, if there are 31 more female than male students, that means the number of females is 31 more than the males. 31 more than the males. So how can we write the number of females in terms of males? Well, it's 31 more. So if we have the number of male students, which we already called x because we don't know how many, and we add 31 to it, that should give us the number of females, right? Because there are 31 more females than males. So x would be the number of females in the class. X plus 31 would represent the number of female students. So x is the number of males, x plus 31 is the number of females. Cool. Now we're ready to go about. We have our expressions created. We understand the relationship between them. Now we're going to write our equation. So what do we know? Let's write it out now. We know that the total number of male students plus the total number of female students in the class equals the total students that are enrolled in the class. That's a fact. So what we can do is take this relationship that we know and apply the expressions we've created as well as any other numbers that might be useful in our problem. The number of male students we're going to replace with the variable x because that's what we called it, the number of male students. The number of female students we said was 31 more, so we could represent that with x plus 31. And when you add up the number of male students plus the number of female students, that gives you the total number of students enrolled in the class. And that is given to us in the first sentence. A university calculus class has 145 students enrolled, so that's equal to 145 total students. This is our equation. This is the hard part, getting to this point. From here, it's now just solving our linear application or linear equations like we've done previously. So I'm going to go through this rather quickly and just post the steps quick for you. We simplify both sides by adding the x's. We use reverse operations to remove the 31 from the left side and move it to the right side by subtracting. We complete the problem by dividing both sides by 2. This gives us x is 57. So now let's state the final answer to our problem. X is 57. Go back up to the beginning, and what did we say? X is 57. So that tells us that the total number of males in the class, so the number of male students, is equal to 57. And the females, remember the females are 31 more. So if you add 31 to 57, you'll get the total number of females, and I'll do that quickly in my head. You guys can write it out. The total number of females is 88, which again, you get by taking 57 plus 31, because there's 31 more females than males. Okay. So our final answer is 57 males, 88 females, added up, and it should give you a total of 145 in the class. Moving on, let's look at our second application problem. We begin by reading through it. The water footprint of an item is defined to be the volume of fresh water required to produce that item. In the Netherlands, the water footprint of a 150-gram beef burger is 25/4 as much as for a 150-gram soy burger. If it requires 1,160 liters of fresh water to produce both a 150-gram beef burger and a 150-gram soy burger, how many liters are needed to produce each type of burger? Wow, that's a big problem. But don't be too intimidated. Really, what are we looking for? Well, we can discover by looking at the last sentence. We are looking for the number of liters of water that are needed to produce each type of burger, the two types of burgers, the beef burger and the soy burger. So let's write that information out right here and assign variables to it. Okay, so as we mentioned, we're looking for two things: the number of liters of fresh water to produce a beef burger and the number of liters of fresh water to produce a soy burger. Now, one of these we're going to assign the variable x before we get started. So let's go back and look here again, because there's a comparison statement right here. The water footprint of a 150-gram beef burger is 25/4 as much as for a soy burger. So it makes more sense after reading that phrase to let x be the number of liters to produce a soy burger. And then it says that the number required to produce a beef burger is 25/4 as much. So we could express that as 25/4 times the number of liters for a soy burger, or 25/4 x. So we have two expressions, the one for the beef, the one for the soy. We are ready to write our sentence and our math equation that we need to solve. So let's do that. Our problem tells us that to produce both a beef burger and a soy burger, it requires 1,160 liters. So we can write the sentence: the number of liters for beef plus the number of liters for soy is 1,160 liters. Let's substitute our variables in, like last time. So the number of liters for beef, we're going to replace with our expression 25/4 x. The number of liters for soy is simply x. And together that gives us 1,160. All that's left to do is solve this equation, this linear equation with one unknown. It's got a fraction, so the first thing I'm going to do is multiply each term by 4 to clear the denominator. Multiplying each term by 4 gives us 25x plus 4x equals 4,640. Continuing on, simplifying and solving, I'll just put the steps very quickly for you. Combining the 25 and 4x gives us 29x. Dividing both sides by 29 gives us 4,640 divided by 29, which is 160. So we finish the problem by actually going back and making sure we have the correct answers and they make sense. So we now take 160 and put it in place of x. 160 was the water footprint for soy, the number of liters of water required to produce a soy burger, so the water footprint for soy. So the water footprint for a soy burger is 160 liters. And then we go back and we have to find the number of liters for the beef burger. So we'll write down the water footprint for the beef burger. And so we'll take 25 fourths times 160, and that will give us the following. The water footprint of a beef burger is 1,000 liters, which we obtain by taking 25 fourths times 160.